Consider f of x equals x squared plus 4x plus 1. And looking at the table of values as we create them, we're going to estimate the limit as x goes to negative 1. Now, in order to evaluate a function at a lot of different places, it's best to use the calculator with the table feature. And to use the table feature, you just put your function in y equals as if you were going to graph it. All right, so we use x squared plus 4x plus 1. Just plug that right into the y equals. Make sure your table is set up properly. You just want to make sure the independent variable is set to ask. That's all that matters. And go to second in table. If you have anything already evaluated, just delete that. That's no problem. And we're going to start evaluating the function at these given x values. So at negative 1.1, just to check things out, it agrees at negative 2.19. That's great. Negative 1.01, we get negative 2.02. And it actually doesn't come out to exactly that, but that's okay. Well, actually, I tell you what, let's write it out as negative 2.0199 just to be safe. All right, the next value of negative 1.001 comes out to negative 2.001999. Well, you know what, I'll just do that. That's fine. I think that's fine. Negative 1.0001, and that comes out to around negative 2, but if you'll notice, it's not quite negative 2, it's just slightly above. So negative 2.0002. But you can clearly see the pattern approaching x equals negative 1 from the left. These values are approaching negative 2. All right, now as we approach from the right, so values that are slightly larger than negative 1, we'll just switch up here, enter those, so negative 0.9, negative 0.99, negative 0.999, and so forth. So it looks like I've got negative 1.98. The next one was negative 1.998. And this one says negative 2, but yeah, it's actually 9998. So, okay. As we approach negative 1 from the right, the y values are also approaching negative 2. Since the limit from the left and the limit from the right agree with one another, we have negative 2 as our limit.